So I've been running through quite a couple of tests with the Sonos Ray. Now I have it and I can do hands-on frequency sweeps to measure the response curve and show it to you. But before I did that, I actually ran through a lot of times. I went through a couple of rounds, and the reason is I just couldn't comprehend what was happening, right? When I tested the Sonos Ray, the result wasn't as I expected. So upfront summary, I'm going to tell you this first because I actually did quite a bit of testing on the Sonos Ray and I was slightly confused because it sounds like it performs a little bit better than the Sonos Beam Gen 2 and I might actually like the sound from this just a tad more. So now I'm doing all the frequency sweeps using my setup right here. This is a mini DSP UMic 1 which is being fed via USB to my MacBook Pro here, which is running REW software. It will emit a series of notes or tones from 20 Hz all the way to 20 kHz through AirPlay 2 to the Sonos Ray and subsequently the Sonos Beam. When it plays it back, the mic will pick it back up and it will measure whether it is hearing 20 Hz as 20 Hz, whether it's hearing 20 kHz as 20 kHz, and at what volume for each of these frequency, thereby forming the whole entire frequency response chart all the way from 20 Hz to 20 kHz. So let's jump right into this. I actually did a couple of tests already. I'm just going to go through one more round and average everything out so that you will see an averaged response from both the Sonos Ray and the Sonos Beam Gen 2, and I'll explain to you why I was so puzzled. So first thing first, I've got to get everything on the same network, and after that I'll set the MacBook to AirPlay 2 to the Sonos Ray. Volume is going to be set at 75% and the mic is placed about 8 inches away from the Sonos Ray to pick up as much signal as possible, ignoring room noise. And REW will now start the frequency sweep and record what it hears. So what we have here at this distance, the mic is actually picking up the Sonos Ray and is outputting about 100 dB at the peak 75% volume on the Sonos Ray. Now I'm going to be switching over to the Sonos Beam and we'll see how that compares. Okay, I've saved the average. Now let me just switch over. So this is a much larger soundbar. Okay, so that was the final test for the Sonos Beam Gen 2. Let's average everything out for the Sonos Ray and the Sonos Beam Gen 2, and I'll see you in just a bit with the frequency response curve. So I used the frequency response curves, which I showed you my testing earlier, to confirm what I think, and I'll run through those in a while if you stay on beyond this summary. Too long, didn't read? I actually think the Sonos Ray sounds a little bit louder than the Sonos Beam Gen 2. Of course, loudness is not everything, so if you could, stay on and we'll discuss a little bit more about the Sonos Ray. So I was very curious to test the Sonos Ray for myself because at the launch event where I was invited, it sounded suitably impressive, but because it was a very noisy location and there were lots of people around, I couldn't do any form of critical listening, and not only that, I couldn't compare it with the Sonos Beam or the Sonos Arc at my home environment. So I was very happy to actually receive this. Now holding this in my hands, it feels really small. So there'll be a couple of things I want to talk about and I'll split it up into 3 sections. The first, I'll be talking about the Sonos Ray itself. The second, I will be doing a frequency response sweep and I'll put up the curves like I do in my videos to talk to you about the frequency response of the Sonos Ray as tested by myself. And I will actually bring up the Sonos Beam Gen 2 for a very quick comparison as well. And lastly, I will leave you with a binaural recording using the Zoom H3 VR to record from the Sonos Ray so that you can, at the very least, try to proxy how it sounds like if you were listening to it yourself in the store. But of course, YouTube compression as well as recording limitations may not convey the full experience of listening to the Sonos Ray for yourself. So first thing first, out of the way, the Sonos Ray is a budget soundbar at $279 US. And bear in mind that it has no 3D audio. There is no DTS-X and there's no Dolby Atmos. Not that Sonos supports DTS-X, but Sonos Beam Gen 2 as well as Sonos Arc, the other two current lineup in the 3 soundbar lineup from Sonos, actually supports Dolby Atmos. This soundbar, the Sonos Ray, does not support Dolby Atmos. And in terms of size, it comes in at 56 centimeters wide. I did a comparison video across the Sonos Ray, the Sonos Beam Gen 2, as well as the Sonos Arc, comparing all the physical dimensions and whatever differences there are. If you are interested, do check out that video. I'll be linking it up here. So very quickly, there is also no mic here. It will still be able to do TruePlay if you are running an iOS device or the iPad. And the only connection to your TV is actually through an optical port here. So you will not be able to put in any HDMI cable to carry sound from your TV using the ARC port or the eARC port. And therefore, you are limited to Dolby Digital 5.1 through the optical port right here. So this speaker actually has 4 drivers inside. I can't remove the grill, obviously, so I'm just going to talk you through very quickly. There are 2 mid-range drivers positioned to the left and right of the center line here, and there are then 2 more tweeters positioned to the side, being guided by a split wave guide, which will throw sound a little bit to the left and a little bit more to the right. And finally, this is a ported design. So Sonos has done ported design speakers before. I do believe that the Sonos Sub is a ported design. There are 2 drivers inside the Sonos Sub and both of them are ported. Now, ported design allows a speaker to sound a lot louder in the bass department than the size actually suggests. And I also did a Symphonix picture frame review, which actually employs 1 bass driver and 1 tweeter in a ported design, and that gave so much bass. I was so impressed. It is now my favorite Symphonix speaker. And the ports are actually in a U-shaped format here. So ports are tuned specifically to allow for more bass output from this small diminutive sized soundbar, which measures only 56 centimeters from left to right. And because the drivers are positioned in the middle, the active drivers are, basically up to this point here. This is the port and this is the open port for the other side of the speaker. Every single driver arrangement is made to fire forward. So there are no speakers firing to the left or the right, nor are there any speakers firing to the top like the Sonos Arc. Even the Sonos Beam had the side speakers over here and here firing 45 degrees to the left and the right. This Sonos Ray, although it's slightly angled to flare outwards, are firing all the sounds forward. So technically, you can put it in the TV console, a cubby hole, which has no additional space to the left and the right, and it should not affect the sound quality and the directionality of the speaker. And Sonos claims that this uses a phase array arrangement such that it will be able to create a much larger soundstage than this small little soundbar size under 2 feet suggests. So if you're not sure how phase array works, I'm just going to try to explain it in simple terms. So when you're firing something to the right, my right, okay, there is actually an anti sound wave in a kind of like out of phase way to the left, firing outwards this side. So if you may, you can think of it as it's trying to cancel the sound from this wave so that you'll hear more of this on your left and less of this on your right. So you get a bell that goes off in this direction. It fires the bell in its correct curve outwards, and it will then generate an inverse curve of that bell sound on this side, firing it out this side. So it seems as though it's cancelling the bell sound from this side so that you hear less of it this side, thus creating an impression of a larger sound stage. So I kind of have covered everything in this soundbar. It is a very simple soundbar. Really not much to talk about it. It's available in black and in white. The front grille is polycarbonate. There are touch sensitive buttons at the top. There are 2 screw threads for the back for wall mounting. I haven't seen the wall mount yet. But otherwise, everything is like what a Sonos soundbar does. And if you need any other information, I welcome you to look at any other channel on YouTube that's talking about the Sonos Ray. I'm sure you have done your research and you'll find a lot of information over there. But if you are coming to this particular channel, I suspect you are looking for things that you can't actually find on other channels. And the thing I'm going to be going on to next is the frequency curve. So when I test speakers, I use REW software that's running on my MacBook Pro that is connected to a mini DSP U-Mic 1, which is a high quality USB microphone that is specifically tuned to pick up sounds that are being played back, recorded, and when REW throws out a signal range from 20 Hz all the way to 20 kHz, it plays back through the speaker, through the target speaker. The mic will then pick it up. Are you playing 20 Hz? Yes. Are you playing 20 kHz? Yes. So in every frequency in between, it will pick up the levels that it's throwing out, and thus it results in a curve. So without further ado, let's pull out the frequency curve. I'm not sure if I'm going to pull it up here or maybe just here. I'm going to pull out the curve in green first. So this green curve represents the Sonos Ray. Now you will notice that there is a peak at about 150 Hz. So that particular peak right over there, it represents a strong bass. Now, if you look at how this curve is being shaped, you will know that Sonos tuned the Sonos Ray to sound quite bassy, and it is being enhanced by the fact that there are two ports here, two U-shaped ports inside, which will enhance bass frequencies. But do bear in mind that when I do frequency response sweep, it measures every sound that is being played. So a loud bass doesn't mean a good quality bass. In this particular case, I do hear the bass, but at very low frequencies, I can actually hear some chafing sound. So the chafing sound is when the air blows through the whole port and the turbulence inside causes the air to move at an inconsistent speed. So it's something like, I don't know, it's like blowing raspberry, like I don't know how to simulate that sound, but I have heard it when I tried to push the Sonos Ray a little bit too much. But ports are not new principle. Ports have been around for a very long time, and a lot of subwoofer manufacturers, a lot of small speaker manufacturers, they actually put a port instead of relying on a sealed design because it gives out more bass output without requiring too much power from the amplifiers. And because this is a relatively small soundbar, you're not going to be able to put a big power supply inside. You won't be able to fit too many amplifiers inside. There are only 4 amplifiers driving the 4 drivers, so I don't suppose that they are able to squeeze in a lot more power into this. Now, if you are interested, I'll be measuring the peak power output from these speakers and compare them with the Sonos Beam and the Sonos Arc. So if you're interested in that, stay subscribed to this channel and I'll see you in those videos. But meanwhile, let me finish up with this particular green curve here. Now from the peak at 150 Hz, you will see that it starts tailing all the way off until about 2 kHz or so before it starts picking up and climbing all the way up to 10 kHz, after which it will then tail off again. So on its own, this green curve doesn't tell you a lot. It doesn't tell you what to expect out of this Sonos Ray. But what I'm going to do next, I'm going to be pulling out the frequency response chart for the Sonos Beam Gen 2, and it's going to come in red. Surprise, right? I didn't expect this. I suspected this at first, but I didn't expect that, right? When I heard the Sonos Ray, it sounded really, really big because the Sonos Beam, while it's not a huge soundbar, it was reasonably standardized size, right? Quite compact still. But when you look at the Sonos Ray, it cuts away 4 inches, right? 2 inches on each side. So basically about this much difference in terms of the size difference between the Sonos Ray and the Sonos Beam Gen 2. And up front, it looks small, it looks tiny, but to have that kind of sound being output by the Sonos Ray, I was kind of taken aback. So when I did the frequency response sweep, it confirmed my suspicion. It actually puts out more sound than the Sonos Beam Gen 2 at below 3 kilohertz. So if you look at where the intersection is at 3 kilohertz mark, and below 3 kilohertz, the Sonos Ray is actually putting out more volume than the Sonos Beam Gen 2. So try beating that. But of course, the Sonos Beam Gen 2 then takes over from 3 kilohertz all the way up to 10 kilohertz before they swap places again. So the Sonos Beam Gen 2 actually sounds better in the mid-range and slightly above. Well, let me change that word. It is not better, it sounds louder. If you look at the driver layout of the Sonos Beam Gen 2, it has 5 drivers, right? Let's discount the bass radiators, but the 5 active drivers, there's one tweeter that's right in the middle of the Sonos Beam Gen 2 firing forward, and there are 4 other drivers to the left and the right and all the way to the sides firing front and sideways. So when you're picking up frequencies in the higher registers, it comes from the tweeter. And because of where I position the mic, the Beam Gen 2 is actually throwing out the higher frequency signals directly into the mic. So the mic should be picking those up right from the front. Whereas for the Sonos Ray, this particular one here, the tweeters are actually all the way to the left and to the right. Okay, so it fires sideways. So in a way, you are catching from the mic, you're catching the sound frequencies at the higher frequencies a little bit off axis, because the waveguides and the position of the tweeters are actually firing the Sonos Ray tweeter high frequencies slightly outwards, not directly to the middle where the mic is. So that would explain how the Beam actually sounds a lot louder in the higher frequencies than the Sonos Ray. But all in all, the Sonos Ray actually puts out very, very decent sound, and I was actually very, very surprised, because it is supposed to be a budget soundbar. It is supposed to be a little bit cheaper than the Sonos Beam Gen 2. Of course, it doesn't have HDMI eARC. It doesn't support Atmos. And of course, the build cost, the material cost of this Sonos Ray is going to be a little bit cheaper, but they could have kept selling the Sonos Beam Gen 2. The R&D would have been already invested. They will just keep reaping the benefits from there. But this one, this smaller speaker, this smaller soundbar, actually, I'm suitably impressed. In fact, I'm very tempted to test how this single $279 soundbar is going to sound compared to a pair of Sonos One SL, which a total cost will come up to $398. Food for thought. So this is a very interesting soundbar. I think I'm going to be listening to this quite a bit more over the coming weeks, but I'm going on a holiday very soon. So by the time you see this video, the next day I would have been gone, and I'll see you in a week's time from there. I'm not going to tell you where I'll be heading. Maybe if I make a video out of it, I will share with you. But meanwhile, before I leave for that, I'm going to leave you with a sound demo. Now, this sound demo is going to be recorded using this Zoom H3 VR. The Zoom H3 VR is actually sponsored by CD Music, and CD Music has been kind enough to understand that I need proper binaural 3D recording gear such that I can capture full soundstage instead of using a mono microphone. So you should be able to benefit from that. I'm going to be recording it this way. I will be placing the H3 VR right here, and I'll be playing some music from here so you can hear for yourself how this sounds like. Of course, use it as a proxy. It is not going to be the most accurate sound, but this will be the best effort recording. I'm going to be turning off the air conditioner and I'll start playing some sounds from here. So enjoy the song, and I'll see you when I come back from my holiday. So if you have any questions on the Sonos Ray and any requests for videos, shoot them my way in the comment section down below, and I'll see you when I come back from my holiday.